Question 7 says a rough plane is inclined to the horizontal at an angle alpha where tan alpha equals 3/4. So the first thing I'm going to do, I'm going to work out what sine alpha and cos alpha are. So if I mark that angle as alpha, it's a right angle triangle. So if tan alpha equals 3/4, opposite over adjacent, 3/4. Now this is a 3, 4, 5 Pythagoras triangle. So then I can work out straight away what sine alpha is. Sine alpha is opposite over hypotenuse, which is 3/5, and cos alpha equals adjacent over hypotenuse, which is 4/5. Now this is our angle alpha on the diagram. Now let's mark other forces on the diagram. We've got a particle of mass m, so its weight goes down there and is mg. The dotted line that I put down here as well, this angle is also going to be alpha. We're going to have a normal reaction. Now it says a particle of mass m is then projected up the line of greatest slope. So if the particle's going up, friction is going to oppose motion. So friction is going to be down the slope. And we're asked to try and find mu in the question. Now in these questions where we've got a mass on a slope, there's always three equations that we have to set up. We have to set up an equation of motion parallel to the slope, perpendicular to the slope, and then we have f equals mu r. So the first one I'm going to do, I'm going to mark the acceleration on here. Now it tells us that it's decelerating, so I'll put a double arrow on there, and a equals, it's decelerating, so its acceleration is going to be minus 4/5 g in that direction. So first of all, I'm going to set up an equation of motion parallel to plane. So equation of motion parallel to plane. And the direction that I'm going to make positive is going to be in that upwards direction there. So we've got mass, which is m, times our acceleration is minus 4/5 g, equals, we've got that force F, it's opposite our motion, so that's minus F. And then we've also got this force here. Now, coming down here, it's opposite that there, so it's going to be minus mg, which is the weight down, and it's opposite there, so it's going to be sine alpha. Now, let's put some numbers in that we know for this here. We know we've got this is minus 4/5 mg equals minus f minus, now sine alpha we got from up here is 3/5, so it's going to be minus 3/5 mg. And I'm going to refer to this as equation 1. I'm numbering that there. That's my first equation. Second equation I want is equation of motion perpendicular to plane. So let's write equation of motion, and it's perpendicular to plane. And the direction I'm going to put that in is an arrow up to the left there. So what's our acceleration perpendicular to the plane? Well, it's 0. So we've actually got m times 0 equals, what have we got in this direction? We've got an r in that direction there, so it's r minus, and then it's this force that comes down here. This is mg cos alpha. So it's going to be r minus mg cos alpha. So let's rearrange that. 0 equals r minus, cos alpha is 4/5, so it's 4/5 mg. And I'm just going to number that as equation 2. Now the last equation we want to set up is to do with limiting friction. So with friction, so I'll detail what I'm doing with this here. Friction, F is going to equal mu r. And what do we know already? Well, we know already from number 2 that R equals 4/5 mg. So I'm just going to rewrite this as F equals 4/5 mg times mu. And I'm going to call that equation 3. Now the rest of part A is just manipulating the algebra. So if we substitute F into equation 1, we're going to get minus 4/5 mg equals minus 4/5 mu mg minus 3/5 mg. Now you might notice here we've got mg in all of these, so I'm going to cancel through mg in all of these here. We've also got a denominator of 5, so I'm going to times through by 5. So timesing through each term by 5, I get minus 4 equals minus 4 mu minus 3. So if I bring my mu to the left there, I get 4 mu equals, bring the minus 4 to this side, I get plus 4 minus 3. So 4 mu is going to equal 1. So the answer to part A is mu equals 1/4. Now for part B of the question, it asks whether the particle will remain at A on the plane or whether it's going to come down. So I've drawn a sketch. Now this time friction is going to oppose the motion. If the particle is going to move down, then we'd have to assume that our acceleration has got to be greater than 0. So I'm going to set up an equation of motion parallel to the plane with down the slope in the positive direction. So we'd get mass times acceleration is going to equal, it's going to be this force dragging it down, which is mg sine alpha minus F. Now, if the acceleration, if this is going to be greater than 0, that's only going to happen if mg sine alpha is greater than F. That means this force coming down the plane overpowers this frictional force, then it will move. So we know that mg sine alpha has got to be greater than F. So let's have a look. So if we look back to part A, in part A we had F equals 4/5 mu mg. Well, let's substitute. We got our mu, didn't we? So our mu was, so we got 4/5 times 1/4 times mg. That 4 cancels with that 4 there. So we're left with our F comes to 1/5 mg. Now, what's our force down the plane? mg sine alpha. So the force down the plane is going to be mg sine alpha. So sine alpha is 3/5 times mg. Now if I look at these, if I number this one number 4 and number 5, 5 is bigger than 4. So this force here is bigger than that force F. So as 5 is greater than 4, the particle will move down the slope.